Okay, so let's look at another example. We're going to find the least squares line for the points 1/2, 1, 1 1/2, and 2 3. So let me draw a picture of these points. So 1/2, 1 is here, 1 1/2 is there, 2 3 is here. And what is a least squares line? So let's just draw a random line here, slope 1 line with intercept 0. Least squares line is a line that minimizes the square error. So it's a line that sort of fits these points the best. And when I say square error, what I mean is I take this distance between the line and the point and I square it, creating this little square. So I have these little squares associated with each error, and we want to minimize the area of those squares, hence the name least squares. So we want to minimize the sum of these square errors. Okay, so let's make a little table here. So we'll start with the point. We'll find the y. We'll look at the y value of that point. We'll look at the y value of the line, just a general line, and then we'll look at the difference between the point and the line and square it. So the point, first point is 1/2, 1. The y value is 1. And the line, if this line is, let's call this line y equals mx plus b. The line, if we put in 1/2, is going to output m times 1/2 plus b. We don't know the equation of that line, so we're just doing it in general. And then we're going to take the difference of these two things. So we'll have 1 minus m times 1/2. Let's rearrange those. So 1/2 m plus b, and then we'll square that. Like so. Do it again. So the y value is 1/2 this time. We'll do m times 1 plus b, because that's the x value plugged into the line. And then we'll take the difference of the line and this 1/2. And then last point, 2 3 has a y value of 3 and a predicted y value, least squares line value of m times 2 plus b. So we'll get 3 minus 2m plus b squared. Oops, I just saw that I put a square in both places there. So it needs to look like that. Okay, so this expression here is literally the area of this little square for a general line. We don't know the equation of the line, m and b change, but if we knew an m and b, then, you know, if we put another line here, let's say we had this line here. Let's say we had this line here. Then if you put in our points again, then the squares would change. Those would be our squares. This is a worse line here. But if you knew the m and the b of this line, then these would calculate the areas of those respective squares. Okay, so we want to sum all these squares together. We're going to call this f. Let's do it in red to indicate. So the sum of the squares, call it f, is going to be this term plus this term plus this term. And if we expand these terms and combine like terms, we'll get 5.25 m squared plus 3b squared plus 7mb, and you can do this at home. It takes a little while, but it can be done by hand. I can attest to that. So this is our function. It's just the expansion of these three squares added together. Okay, so now we have our function, and now we can minimize this function, and if we minimize this function, we're minimizing the square areas, so we're finding our least squares line. The m and the b that minimize this function will be the least squares line, and that's super cool, super cool. We're doing a least squares line by hand. Usually we use calculators to do this, so we're kind of seeing the machinery underneath a least squares calculation. So the gradient of this is the derivative with respect to m. We're going to call m our first variable, so maybe I should just make that clear here. So m is our first variable, and b is our second variable. So when I take the derivative of this, I'll get 10.5 m plus 7b minus 14. And then the derivative with respect to b is 6b plus 7m minus 9. And the 10.5 goes to 0 each time. So this is equal to 0. And so each of those components is equal to 0. So let's solve for b here. So we get b equals 14 minus 10.5 m over 7. Moving these two terms to the right hand side, divided by 7, which is 2 minus 1.5 m. That's my b. And then I'll have 6 times 2 minus 1.5 m plus 7m minus 9 equals 0. I'm substituting this in to the second equation here, which has to also equal 0 for the gradient to be 0. And I'll get 12 minus 9m plus 7m minus 9 equals 0. So that'll be 3, and then negative 2m, which means m is 1.5, which then if I put back in here, back here, I'll get b equals 1.5 squared is 2.25. So this is negative 0.25. Okay, so let's draw this least squares line. So we have 1/2, 1, 1, 1/2, and 2, 3. And it has slope of 1.5 and intercept of 1/4. So 1 1/4 plus 1.5, negative 1/4 plus 1.5 is 1.25, so that's right there. That's our line, and so our square errors are these. The claim is that this area is the minimal area. Okay, so for time's sake, we'll leave the second derivative test for homework, but we finished the problem. We found the least squares fit line by hand, which is pretty cool, and we can check this answer with our calculator, and we'll see that it is indeed correct. You could also throw those points in a computer and see that it's correct. And we're really seeing, once again, the machinery behind finding a least squares fit line, which is pretty sweet. All right, that's it for this lecture. I'll see you back here for the next one.